All right, so let's talk about electric current and focus on that. Remember again, we pretend as if it's the positive charges that are moving around the battery, so we will often think about it that way and draw it that way. So, what is electric current? Well, it's the flow of electrons, but we're just going to focus in on the charge. We're not going to think about the electrons themselves moving. So, electric current's the flow of charge, and the symbol for electric current is capital I. It's measured in something called an ampere, most often shortened to an amp. And the symbol for an amp is a capital A here. So, what is an ampere? What's an amp? Well, an amp is a coulomb per second. So, if you say there are 10 amps flowing in a circuit, that means there are 10 coulombs flowing by a given part of the wire at any given moment in time. The word ampere comes from this gentleman right here, André Marie Ampere, who lived from 1775 to 1836. He was a French electrical physicist and also the 1830 Paris-Hungary Hippo champion. So here, in a sense, is how we could define electric current. Electric current is the amount of charge flowing by in a given amount of time. Think about it like the amount of cars flowing by on a road. Not how fast, right? Because often we might think of current and we think of current in a river and we may think of how fast the river is flowing. But the way we want to think about it is how much is flowing. So you may view a large road in Atlanta or LA or something that still has a fair amount of cars traveling on it because it's so wide of a highway, even though maybe it's rush hour and they're not going that fast. But you could still have a large current in that sense if you count current as the amount of cars passing by per second. Where some lonely Morgan Township road, even though a car may go zipping by fast, that would actually be a low current because there wouldn't be that many cars per second going by you. So if we want to think of current in this way, again, with a river, just to give another analogy, it wouldn't be how fast the river is flowing, but how much volume of water is flowing by that river in a given amount of time. So rearranged, by the way, this equation gives us charge is current times time. And so this actually has to do with the amount of charge in a battery. This is called its capacity. Typically, capacity is measured in amp hours instead of coulombs because we need a bigger chunk of charge. So 1 amp hour is 3,600 coulombs, which makes 1 milliamp hour. You might see that on smaller batteries, 3.6 coulombs. If any of you have like batteries that power an electric drill or something like that at home, you will probably see amp hours stamped on the side. Those two things. You'll see the voltage, right? That's the electric potential. That's how much shove there is. So if you have an 18 volt versus a 40 volt battery to power a drill or a table saw or something, that tells you how much the charges are being shoved through the circuit, the voltage. But the amp hour stamped on the side is how much charge they have. So you may have two 40 volt batteries, but one of them's 2.5 amp hours and the other one's 5 amp hours. That means the 5 amp hour one will last longer, all other things being equal there. So this comes back to the batteries. They're all DC, AA, and AAAs are all 1.5 volts, remember, but here's their capacity. In other words, here's how much charge that they hold in there. That is different. So a D has 13,000 milliamp hours, a C has 6,000, a AA has 2,400, and a AAA has 1,000. So how much, we mentioned this before, but the difference between them is how much charge that they hold. And it's also the drain, but we won't focus on this. It's how fast you can pull that charge out. There are two main types of current that you'll see in the US. One is direct current, or anywhere in the world, really. Direct current means the flow of electricity in one direction, and that's what we've been talking about so far. A common source of DC current is a battery, and that is what we are going to focus on this week is DC current. This is the end of Electric Video 1.